What if I told you that everything in the universe is made of strings? Not those kind of strings, but tiny one-dimensional objects called strings. And these strings are the fundamental building blocks of all matter and energy in the universe. It's a mind-blowing concept, but it's the basis of string theory, one of the most exciting and controversial theories in physics. String theory was developed in the 1970s and 80s by physicists like Yoichiro Nambu, who won the Nobel Prize for his work on it. The basic idea is that all matter and energy are made of these tiny vibrating strings. Just like how a guitar string vibrates to produce sound, these strings vibrate to produce different particles. The type of particle produced depends on how the string vibrates. So all the different particles in the universe are just different vibrational modes of these strings. But there's a catch. These strings are not just one-dimensional objects. They are actually 10-dimensional. Yes, you heard me right, 10 dimensions. We only perceive 4 dimensions in our everyday lives, 3 spatial dimensions, and 1 temporal dimension. But string theory requires these strings to have 6 additional dimensions. So where are these extra dimensions? They are not visible to us because they are curled up at extremely small scales. These tiny dimensions cannot be observed with current technology, but string theory predicts their existence. One of the main reasons for developing string theory was to unify the 4 fundamental forces of nature: gravity, electromagnetism, and the strong and weak nuclear forces. These forces are described by different theories, and physicists have been trying to find a way to combine them into one for over a century. String theory promised to be a framework where all these forces could be explained by the interactions of these tiny vibrating strings. Another motivation for string theory was to solve some of the problems of general relativity, Einstein's theory of gravity. One such problem is the singularity at the center of black holes and the Big Bang. These singularities are points of infinite density and curvature, and they represent the breakdown of our current understanding of physics. String theory attempts to avoid these singularities by providing a different description of gravity at very short distances. Despite its elegance and mathematical beauty, string theory has not been tested experimentally, and it remains highly controversial. This is mainly because the strings are so tiny. They are much smaller than the Planck length, which is the smallest possible length that can be measured with current technology. So we cannot directly observe strings or test the predictions of string theory. Some physicists argue that string theory is not falsifiable and therefore not a scientific theory. Others argue that it is incomplete and that it needs to be modified or extended to describe the phenomena that it predicts. Despite the controversy, string theory has had a profound impact on our understanding of quantum gravity and has inspired new research areas in physics and mathematics. So next time you look up in the night sky, remember that everything you see is made of these tiny vibrating strings. And if you listen closely, you might just hear the music of the spheres. If you enjoyed this video, please subscribe for more videos about space and science. Thank you for watching, and I'll see you next time.